Hello and welcome to a new video on IGCSE Physics Classified Paper 2. In this video, we'll be discussing the topic of work. You should know that work is equal to force times distance, and that these two quantities must be parallel to each other. The force and the distance must be parallel to each other. We'll begin with concept questions. The work done by a force is related to the magnitude of the force and the distance moved in the direction of the force. In the direction of the force means parallel to the force. Which equation for W is correct? We just said that W equals F times D is the correct equation. So the correct choice would be choice D. Force F acts on a body and the body moves a distance D in the direction of the force. Which expression for the work done is correct? Again, work equals force times distance is the correct expression. So A would be the correct answer. The student does some simple exercises. In which exercise is the most work done? So you have to identify what force you're acting against in each case. And by the way, you have to remember that the force has to be parallel to the direction of motion. So in this case, the force is vertical and equal to 10 because it's the weight of the object. In this case, the force is vertical and equal to 20. Here, the masses are irrelevant because the weight acts downwards and we don't care. So we only care about the horizontal force here, F equals 4. And here as well, we don't care about the mass. We just care about the force, which is 2 newtons. And the distances are 2 and 1. And 1 here as well. And 2 here as well. And remember that weight here is meant as a force. So as not to confuse between weight and work. We're going to use W for work instead. So what is the work done in each case? The work done here is 10, 1 times 10. The work done here is 2 times 20, which is 40. The work done here is 4. And the work done here is 4 as well. We just multiply the force by the distance. So it's obvious that the most work done occurs in case C. The diagram shows athletes training by stretching springs. Each spring has the same stiffness. Which athlete does the most work? So we said that work is equal to force times distance. So in order to maximize W, we need to maximize F and maximize D because they're multiplied by each other. So you want them both to be very big numbers. Now, this distance is 0.6 compared to 0.8. We definitely know that 0.8 is going to be the correct answer. So is it B or D? The difference is that in D, he's using 2 springs at the same time to stretch simultaneously. So obviously, he's doing the most work in case D. A box of mass M slides down a slope of length L and vertical height D against a frictional force F. As the box slides down the slope, it loses gravitational potential energy and it does work against friction. Which row gives the loss in gravitational potential energy and the work done against friction? So they're testing 2 concepts here. The first concept is that you should understand that gravitational potential energy has to do with vertical height. Has to do with height, not distance traveled. So you're looking for something that has to do with the letter D, not the letter L. So C and D are automatically discarded. And work done has to do with being parallel to the force. So the distance and the force have to be parallel to each other. So the correct letter here is letter L because L and F are parallel to each other. So we disregard FD as well. So the only correct choice here would be choice A, where the gravitational potential energy depends on the vertical distance and the work done depends on the parallel distance, which is A. So A is the correct choice. The diagrams show four bodies moving in the directions shown. The only forces acting on the bodies are shown in each diagram. Which body gains the most kinetic energy when moving a distance of 1? So you need to understand that the work done translates into gained energy. So the body that gains the most energy is the body that receives the most work done, in a sense. So we're looking for the greatest work done. And since work equals force times distance, and we are told that they all move a distance of 1, so the distance is irrelevant because they all have the same distance. So we're just looking for the maximum force in this question. And it has to be parallel to the direction of motion, of course, in the same direction as the movement, so that it would gain kinetic energy, it would have more energy, not less energy. So we have 10 up here because we have 20 minus 10. So we have 10 up. So that's 10 positive. And then this is also 10 because the force and the movement are in the same direction, both down. This is 0 because 30 minus 30 gives you 0. And C is 15 to the right. So of course, C has the greatest force and the greatest work done. So it gains the most kinetic energy. So C is the correct choice. What needs to be known to calculate the work done by a force acting on an object? You need the force and the distance. You do not need the time. So time, no. Force, yes. Distance, yes. So we're looking at choice B. Time is needed if you're going to calculate the power. But for work, you do not need the time. In a factory, two men X and Y try to move identical heavy boxes P and Q. Man X tries to push P along the floor. The box does not move because an object is in the way. Man Y lifts box Q from the floor onto a shelf. Which man does the most work on the box and which box gains the most energy? So, of course, common sense, who's doing more work, the guy who's pushing or the guy who's lifting? Which is easier to do in real life, to push something on the ground or to lift it up? Of course, lifting up is much harder. So the guy, man Y, is trying to lift box Q, so he's doing the most work, of course. And which box gains the most energy? Box P does not gain any energy because he's pushing against something that's in the way. So the box is not moving, it's not gaining height, has no kinetic energy or potential energy. But box Q has been lifted to a certain height, so it gained potential energy. So box Q is the one that gains energy, and man Y is the guy that does the most work. So the correct choice here is choice D. Man X is doing less work, but it's completely useless because nothing is happening to box P. A student does work by pulling a box across a horizontal floor. She now pulls a second box along the same floor. Which row indicates that the student is now doing twice as much work? So work equals force times distance. If you double both, as in choice A, you get 2F times 2D, and that gets 4W. In B, if you double the first and half the second, that would be 2F times 1 over 2D. And if you multiply 2 times half, you get 1. So that's equal to W. So the work done did not change. For C, if the force stays the same, so F, and the distance is doubled, so 2W, excuse me, 2D, so you get 2W. So this is the correct choice. For D, if the force stays the same and you half the distance, you get half the work. So again, this is wrong. So A wrong, B wrong, D wrong, and the correct choice is choice C. The force stays the same and the distance is doubled. That would give you twice as much work. So C is the correct choice. A weight hangs from a rope. In which case does the force do the most work on the weight? So this is a nice question. It's a bit tricky. if you avoid the trick, it becomes very easy. You're usually used to looking at all the data and trying to make sense of all the numbers in the question. But sometimes there are numbers that are just there to trick you. None of these are relevant. Time is irrelevant completely. When we're evaluating work, time is completely irrelevant. We only consider time when we're evaluating power. So the time does not matter at all. So now it becomes a very easy question. Which of these does the most work? Raising a weight of 1 or raising a weight of 2 or holding it at the same level? Of course, B is the correct choice. The force raises the weight 2, that would be the most work. If you're calculating power, B would not be the greatest power. So that's why it's confusing. But for work, we do not care about time. So B is the correct choice. Now we move on to some questions that require calculations. A force acts on an object and causes the object to move a certain distance in the same direction as the force. Which row represents a situation in which the largest amount of work is done on the object by the force? So you know that work is equal to force times distance. So you can calculate the work for each case quickly. 2 times 40 is 80. 10 times 2 is 20. 20 times 6 is 120. 100 times 1 is 100. So the greatest amount of work happens in C. Again, we want to find where the greatest work done occurs, and you just multiply the force by the distance. So this is 350. This is going to be slightly greater than that, so we can just use the calculator. 700 times 0.55, that gives us 385. And 800 times half gives us 400. And 800 times 0.55 gives us 440. Of course, a smarter way to do this question is to just realize that D has the greatest work done, the greatest force, and the greatest distance. So without any calculations, you could have selected D as the most work done. The box is pulled along a floor by a force of 3. The friction acting is 1. How much kinetic energy does the box gain in moving 2 meters? So you should know that the work done results in a gain in energy. And work done here is force times distance. Of course, we have to subtract 3 minus 1. This is the equivalent of 2 to the right. And it's moving with a force of 2, a distance of 2. So the work done is 4. And therefore, the kinetic energy gained is 4 joules as well. So B is the correct choice. A crane on a building site lifts bricks of total mass 200 kilograms, initially at rest on the ground with uniform acceleration. When the bricks are 5 meters from the ground, they have a speed of 5 meters per second. How much work is done during this process? So the work done is equal to the energy gained. And he gave you 2 pieces of information, 5 meters from the ground and speed of 5 meters per second. So the potential energy here would be mass mgh, basically mgh. And m is 200, g is 10, and h is 5. So this gives us 10,000 joules. And the kinetic energy here is equal to half mv squared. And this is equal to half times 200 times 5 squared. So this is You can use your calculator for this. This will be half times 200 is 100 times 25, 2,500 joules. So the work done is equal to the summation of the energies. It's the total energy gained. So that's 12,500 joules. And therefore, this is equal to 12.5 kilojoules. And the correct choice here would be choice C. So C is the correct answer. And this brings us to the end of our video. I hope this has been useful. Thank you for watching.